Dear students, welcome you all for the one more session on ANOVA models. The objective of this module is to illustrate the application of ANOVA models in two more interesting problems. In the first example, the interaction between two qualitative variables are discussed. In the second example, the application of ANOVA model in the analysis of time series is discussed. These illustrations may help you understand few variants of ANOVA models and their applications. Welcome to the course. ANOVA models contains the independent variables that are all exclusively dummy or qualitative in nature. It may involve single variables with two or multiple categories of levels, or it may also involve multiple variables. With these specifications, ANOVA models can be put to use flexibly in variety of contexts. We saw few of them in the last two modules. I hope you have learnt to use ANOVA models and their uses. Let us talk about the two interesting examples. One is the interaction effect model in ANOVA models. This contains more than two variables. The two variable ANOVA model usually contain the two dummy variables, one for the gender, the other one for the educational qualification. But here you have the interesting third variable, it is the multiplication of the gender and the educational qualification dummies. What does it mean in the practical sense? Beta 1 usually measures the difference between the male and female employees average salary. Beta 2 measures the difference in the average salaries of the literate and illiterate employees. When you measure the difference between the male and female employees, you assume there is no such difference exist between the illiterate and literate employees, and you assume the homogeneity between the male and female employees when you measure the difference between the illiterate male and female employees. But no, this is not the case. They are different, right? They are heterogeneous, and so the heterogeneity is captured in this third variable. So we are including that third variable. Let us see now the meaning of each of the individual coefficients. First one, the will take the conditional average of yi, the salary, given d1i is equal to 0 and d2i is equal to 0, that is alpha, that is the average salary of the female illiterate employees, that is the base category. Base, here the female and illiterates, they are the base category. So, alpha measures the average salary of the female illiterate employees, and the conditional average of yi given d1i is equal to 1 and d2i is equal to 0 is alpha plus beta 1. This is the average salary of the male employee, and beta 1 is the differential average of the male employees over and above female illiterate employees. And now the third one, the conditional average of yi given d1i is equal to 0 and d2i is equal to 1, that is equal to alpha plus beta 2, that is equal to average salary of the literate employees over and above the female illiterate employees. Okay. What is this last one? This is the conditional average of yi given d1i is equal to 1 and d2i is equal to 1, that is equal to alpha plus beta 3, that is the average salary of the male literate employees, Beta 3 is the differential average salary of male literate employees over the female illiterate employees. Now, this will measure the combined effect of the male and literate employees. So, this will give the interaction effect of these two dummies, the gender and literate dummies. Let us demonstrate this with an example from Gujarati book. Let us consider this model. Here there are two dummies introduced, one is for the female, the other one is for race. Here race dummy D3I is equal to 1 if non-white and non-Hispanic and 0 otherwise. D2I is equal to 1 if female, otherwise male. So, this is the dummy variables. We are getting the interaction effects through the multiplication of D2I and D3I. If this is significant, we may conclude that there is a interaction effect between gender and race variables. Let us see one example of applying ANOVA models for the time series analysis. Time series will have 4 components. One is trend, cycle, seasonal and irregular components, cyclical, trend, seasonal and irregular components. In this, the deseasonalizing will help to understand the trend in the time series. So, we may like to have the deseasonalization for the analysis of time series in the trend component. The process of removing the seasonal component is known as deseasonalization or seasonal adjustment. Conventionally, there are 3 methods that are used to remove the seasonal effects or deseasonalizing. First is the moving average method, second is link relative method, third is percentage of annual average method. Apart from these conventional methods, ANOVA, simple ANOVA model can also be used for the same purpose, the removing the seasonal effects from the time series. To deseasonalize, we can use a simple ANOVA model like the one specified below. Yt is equal to beta 1 d1 t plus beta 2 d2 t plus beta 3 d3 t plus beta 4 d4 t plus ut. We already know there are only 4 quarters in an year. For each quarter we have got one dummy. For example, d1t, d2t, d3t, d4t are the dummies for the first, second, third and fourth quarters. So, all the 4 dummies were introduced into the model. To avoid the dummy variable trap, we are dropping the intercept term from this ANOVA model. So, for all the quarters dummy variables are introduced, but the intercept term is dropped. Now, D1t is specified as if the teeth sale is done on first quarter, 0 otherwise. D2 t is equal to 1 if teeth sales is done on second quarter and 0 otherwise. D3 t is equal to 1 if teeth sales is done on third quarter and 0 otherwise. D4 t is equal to 1 if teeth sales is done on fourth quarter, 0 otherwise. As defined, as discussed earlier, the model, the ANOVA model without intercept, the slope coefficients measure the average of the respective dummy category. Here in this case, beta 1, beta 2, beta 3 and beta 4 are the average sales made on first, second, third and fourth quarters respectively. Naturally, the significance of these parameters beta 1, beta 2 and beta 3 are the indicators of the presence of seasonal pattern. For example, if beta 1 is significant, that indicates the presence of seasonality in the first quarter. If beta 2 is significant and also the seasonality of beta 2 the second quarter is present. So, like that the significance of each of the parameters could be interpreted as the presence of seasonal pattern in the time series. Now, we will take the expected value of yt. Yt is equal to yt hat is equal to beta 1 hat d1 t plus beta 2 hat d2 t plus beta 3 hat d3 t plus beta 4 hat d4 t. This is the expected value of yt. This all indicates this all captures the seasonal effect of time first quarter, second quarter, third quarter and fourth quarter. So, this is the measure of seasonality in the time series. The deseasonalization can be done if you subtract this seasonality element from the original time series, that is yt minus yt hat will give the deseasonalized time series, that is yt minus the expression for yt hat will give you the deseasonal data. The wholesale price indices and the indices of the industrial productions are given in the deseasonalized form usually. So, the statistics are all by the industrial statistics and these wholesale price index statistics all come in the seasonally adjusted form. The deseasonalization is done using this procedure. Let us take one example from the Gujarati textbook. This is the US refrigerator sales in thousands between 1978 to 1995. The data is in quarterly form and this is the data, this is the result given. So, naturally we can interpret this coefficient as the average first quarter sales. This can be taken as the average second quarter sales. This is the average third quarter sales and this is the average fourth quarter sales, and all the three are significant, all the four coefficients are significant. So, we will say there exists a seasonality in all the quarters. The seasonality element is present in all the quarters D1, D2, D3, D4, in all the quarters you have got seasonality. This is what now the data says. So, next step is finding. So, for each of the values, for each of the values we can find the yt hat, and this can be subtracted from the yt. This is nothing but actually for the first quarter variables, for the first quarter data we will subtract this one, for the second quarter data we will subtract this one, and for the third quarter data we will subtract this value, and for the fourth quarter data we will subtract this to get the deseasonalized data. So, that is what is called seasonally adjusted data. Let me give you another example of the interaction effect using the ANOVA model. So, I am defining another ANOVA model. Here you have a quantity variable. On the right hand side you have two dummies and one extra dummy is added here. So, that is the special characteristic of this ANOVA model, and that is multiplied or derived from these two dummies, and that is combined D1 and D2. So, this is the combined dummy. This will measure the impact of interaction. Now, let us take yi is the test score of ith student, and D1 is the dummy for student teacher ratio, that is D1i is equal to 1 if class STR of the ith student is less than 20 and 0 otherwise. D2 is the dummy for the proportion of rural learners, that is PRL. D2i is equal to 1 if the class PRL of ith student is more than 10% and 0 otherwise. Now, the conditional expectations can be calculated for this ANOVA model. The conditional average of yi given D1i is equal to 1 and D2i is equal to 1, that is beta 0, beta 0 plus beta 1 plus beta 2 plus beta 3, that is the average test score of doubly deprived in terms of student teacher ratio and also in terms of high proportion of rural learners in the class. And we can again find another conditional average, that is expectation of yi given D1i is equal to 1 and D2i is equal to 0, that is beta 0 plus beta 1, that is the average test score of students deprived only in terms of STR, not in terms of the PRL. So, this will together this the average or the difference of it will give you the effect of PRL, because the impact of rural learners on the average test scores on high SDR class is beta 2 plus beta 3, the difference of it, that is the impact of D2 on D1. Similarly, the impact of D1 on D2 can also be calculated, because let us define the conditional average. yi given D2i is equal to 1 and D1i is equal to 1, that is beta 0 plus beta 2 plus beta 1 plus beta 3. Actually, I have intentionally I have changed the positions of the coefficients. This is the average test score of deprived students, doubly deprived students. Now, again we can find another conditional average of yi given D2i is equal to 1 and D1i is equal to 0, that is beta 0 plus beta 1. This is the average test score of students deprived only in terms of PRL. So, we can find the impact of student teachers ratio on the average test score of high PRL class is beta 1 plus beta 3, actually the difference of it, that is this is the measure of impact of D1 on D2. This intercept term is an interesting term. This is the most privileged students average score, because this is the student who study in the low teacher student ratio class and also studying in the class in which there are very minimal number of rural learners. So, the most fortunate students average is 664.1 score, and if you take the impact of this D1i, we can measure the impact of D1i, the student teacher ratio, as 18.2. The impact of the rural proportion of rural learners is measured by this one, and this one is the interaction effect, right. This is with this we can find the interpretation as discussed earlier. In this model, the impact of D1 is equal to minus 18.2, the impact of D2 is minus 1.9. The impact of D2 on D1 is minus 5.4. Actually, this addition of these two measures, actually this ANOVA beta 2 and beta 3, and the impact of D1 on D2, that is the addition of minus 18.2 plus minus 18.2 and minus 3.5 is minus 21.4. So, this is the measure of impact of D1 on D2. So, this is the measures, basically the interaction effect measures. So, this is how the measures are calculated, the interaction effects are calculated in this ANOVA model. I hope you have learnt to use ANOVA models and their applications. Thank you for patient listening.